Hello everyone, welcome back to Math Concepts for 1.4, Solving Quadratic Equations. So in this section we're going to be talking about how to solve different types of quadratic equations and what technique to use to solve for these. Normally, for this section we're going to use three methods, which usually are pertaining to the group factoring, completing the squares, and also the quadratic formula. And we're also going to use something called the discriminant, and this helps us find how many real solutions there are for the quadratic equation. Usually you might have two answers, but most of them might be imaginary. Some of them might be just real. In order for us to figure that out, we use the discriminant. Sorry. Okay, so first off, what is a quadratic equation, right? So what's the standard form to see it in order for us to kind of distinguish this as a quadratic? So usually we always go in the basis of ax squared plus bx plus c equals 0. This is usually how a quadratic equation will look like, where a, b, and c are all constants, so all real numbers. But also a cannot be 0. Just keep that in mind. A cannot be 0 because then at that point, if it's 0, it's not going to contain a squared, and that leading square is what makes this a quadratic equation. Anything higher than a 1 is considered quadratic. And yeah, so usually we use this in order to distinguish that it's a quadratic equation. So for our first example, just to try to look for it, let's say we have. I want you to find all real solutions, okay? And usually you'll see this in your homeworks or textbooks, whatever you're using, of the equation. So of the following equation, right? So let's say you have x squared plus 5x equals 24, right? So go back to your original quadratic equation, and it says here that it must equal to 0. Here, it's not equal to 0. In fact, it's equal to 24. So what I would recommend, always bring whatever side is convenient for you, either to the left-hand side or the right-hand side. In this case, it's just easier for me to bring that 24 to the left-hand side. So it'll give us x squared plus 5x minus 24 equals 0. Now, since this is in the form of a quadratic, we're able to factor. So this is one of the techniques we could use to solve. So let's try to factor this. Usually, we always go based on the box method, the x method, where the top you're multiplying, the bottom you're adding. So the top one is going to contain the a times c. A in this case is 1, because there's an imaginary 1 there, and c is negative 24. So the top one is going to go negative 24. And then the bottom one, the addition one, is 5. Usually, 5 is your b. In this case, this is 5 here from your quadratic. So now you're trying to figure out these two empty boxes, and one's on the sides. So you're gonna have to figure out what numbers multiply give you negative 24, but add up to 5. And the ones that I found were plus 8 and negative 3. So what you do here now is that you're gonna create parentheses equal to 0, because that's what it's equal to. X plus 8, because we got a plus 8, and then x minus 3, because we got that minus 3. So now we're looking for our solutions. So we're going to split that because we're multiplying. So we're going to have 8 plus 8 equals 0. I'll put a semicolon here. And then x minus 3 equals 0. So x can either be negative 8 and x can be 3. So these are your solutions for example number 1. So now let's say you have another one. Oh, actually, the second method we could use is completing the squares. Usually, this one tends to be the harder one for students, even myself, sometimes, because this one we don't usually use it, but it is useful too. Usually when it comes to a quadratic equation, usually what it entails is that you're gonna have this, right? The ax squared plus bx plus, now this thing is gonna be different. Instead of c, it's gonna be b over 2a squared equals. Now the right hand side is going to be 8x plus b over 2 squared. So as you can see here, it's a bit different. It's not like your original here on your quadratic. But now we have this form. This is to kind of solve for quadratic, or to use the completing the squares for this. So let's say let's say that one of the examples, right? So let's say example 2. Let's say you have x squared minus 8x plus 13 equals 0. And they want you to find, put in brackets, find all real solutions using completing the square. So I'm going to abbreviate it, so I don't have to write the whole thing. So what you want to do here, so first off, just rewrite the whole thing. So x squared minus 8x plus 13 equals 0. Usually for this method, you're going to have to bring your c to the right-hand side, no matter what. Because when it comes to completing the squares, that's always the first method you should do. So then you have x squared minus 8x. Leave some space in between, and then put that negative 13. Now you might be asking, what goes in between here, right? Because we're going to have to do it to both sides. In order for you to figure out what goes inside the parentheses, you're going to be using something, this method, the b over 2a squared. Luckily here, a, we already know what a is. A is 1, because, this imaginary 1 there. And b is negative 8. So you put that in your b over 2a. So b is negative 8 all over 2 times 1, and we're going to square that. So that turns into a negative 4 squared, which gives us a positive 16. Sweet. So now this number is going to go here and here. So you're gonna, whatever you do it on the left-hand side, you also have to do it for the right-hand side. And since you're adding that 16, don't forget that addition. So now, just keep that in mind. And so now your new equation should look something like this. You're going to have x squared minus 8x plus the new number 16 equals negative 13 plus the other new number 16, because we have to do it to both sides. Now, the right-hand side turns into a positive 3. But luckily here, what do they turn to be? Because you're able to factor this out. It's the same as the x minus 4 times x minus 4. So luckily when we do completing the squares, the left-hand side tends to be the easier way to factor, because they're always the same. Here, they're the same. So what you could do, you could do x minus 4 squared equals 3. Now, you're able to square root it. When you do that, do keep in mind that your right-hand side is always a plus or minus. Don't forget about that. And so now, you bring that 4 to the right-hand side. And now you have x equals positive 4 plus or minus radical 3, sorry. This just tells us, again, you're going to have two solutions because of the plus or minus. So it could either be 4 plus radical 3 or 4 minus radical 3. But either or, it's the same thing. And this is you seeing completing the square. So it doesn't matter which one you have. If you're able to use this one, and it just makes your life easier. Now for the last method here is using the quadratic formula. So usually, first off, you're going to have to know what the quadratic formula is. So what you want to do is write a formula for it, right? So the quadratic formula, if I recall, is negative b plus or minus square root of b squared minus 4ac all over 2a. So keep that in mind. We're going to need this for the next problem. So let's say, for example 3, let's say that they're asking you to find all real solutions for the following. So 3x squared minus 5x minus 1 equals 0. And they want you to use the quadratic formula. Well, first off, you're going to need your a, b, and c, right? Because remember, the quadratic formula is as follows. B squared minus 4ac all over 2a. So what is a, what is b, and what is c, right? Because we need those components. Luckily, we do know what those are. A is 3. 3, I'm going to put it right here. B is negative 5, and c is negative 1. So you just plug that in into your quadratic. So you have negative 5 plus or minus negative 5 squared minus 4ac all over 2a. So that turns into a positive, plus or minus 25. That turns into a positive 12 over 2 times, oh, I forgot the 3. Since a, it is 3 here. 2 times 3. So that turns into 6. So next page, that gives us, 5 plus or minus 37 all over 6. And this is our final answer, since we just added the inside, because that's the only thing you could do. And you cannot factor anything out at all anymore. So technically, if they want you to split the answer, like to show what the two answers are. It's either 5 plus radical 37 over 6 or 5 minus radical 37 over 6. So it's either or. It doesn't really matter because they both mean the same thing. Let me put another arrow here. And that is usually the last thing we do in order for us to figure out how to solve for quadratic functions. The next thing we're going to talk about in the next video, we're going to be talking about the discriminant. Usually this helps us kind of know how many real solutions we're going to have for the following quadratics. So keep in tune for the next video, and thank you guys for the amount of support. If you guys liked the video or you guys enjoyed the video, please give it a like or subscribe if you haven't. But yeah, I'll see you guys on the next one. Peace out.